So now that we've met the alkenes and the alkynes, what we call unsaturated hydrocarbons, it's the ability to have other things added to them, so break the double bond or triple bond, have things added to them without breaking the carbon chain itself, we're going to meet, probably for this assessment, the most important reaction of the unsaturated hydrocarbons, so the alkenes and the alkynes. And I'm going to use alkenes as my example here, but we are going to go through a few different examples of monomers, things we start with, in the next video, or the next couple of videos probably. So, addition polymerization means to add molecules together to make polymers. Polymers are really, really big molecules. We call them macromolecules. They've got thousands and thousands, if not millions and millions, of the same unit, the same chemical, repeated over and over, chemically joined together. They are plastics, and some other things are polymers like nylon, so some fabrics are as well, the synthetic ones. So this is where we use, in this case for addition, unsaturated hydrocarbons, add them together to create polymers, and these polymers in this context are going to be our plastics. So the first thing we do is we get our monomers, our things we start with. Now I'm not showing the hydrogens or the rest of the carbon chain. The key part is that they both, the monomer, the thing we start with, the starting material, has got a double bond in it. What can happen is that double bond with a polymerizing agent, which is a catalyst effectively, causes, with a bit of heat, the double bonds to break, but only one part of the double bond. The other part stays intact. So one electron goes to the left and one electron goes to the right. One electron goes to the left, one electron goes to the right. What happens is, in this region here, a new chemical bond is formed between those two monomers. So it makes a new chemical bond. But at the end, at each end, we've got a lone electron. Lone electrons is not anything that's very stable. It's called a free radical, actually. And what it will do is it will rip electrons off other things to make a new chemical bond. So when it comes next to another one of these monomers or starting materials, it will rip an electron out of its double bond to create a new bond. And this will do it to other ones on this side. So it'll create a chain reaction where it gets longer and longer and longer on each side until it basically runs out of monomers. And then at the end there, it'll use things like hydrogen or other things that it's dissolved in to finish off the molecule. So it'll grab those and make a new carbon-hydrogen bond, for example, at each end. So N is representing a really big number. Okay, it could be thousands, it could be millions, it could be billions of our same starting material, and we end up getting this thing here. The little squiggly lines means it goes for a long way to the left and to the right, both directions. We've just taken a snapshot in the middle. And when I show you this with some more specific examples, you'll see that it keeps looking like the same thing, repeating itself over and over and over. So this middle bit is called the repeating unit. It's the bit that keeps repeating itself. Now, in alkenes, it's a lot easier to identify than in alkynes. But again, I'll do a video on that in a moment. So the key thing you need to get is that there is a polymerizing agent required. So something to actually make this happen. That it then, once it starts, it keeps itself going until it runs out of monomers or starting materials, because it causes its own chain reaction with these lone electrons on each side. So the more you add, the bigger your plastic will be. Then when we draw our plastic out as a structure, we can usually find in the middle of it a repeating unit. And that repeating unit sort of links back to the monomer you're going to see in the next video.